Hey, what's up? This is Václav. So, after almost a year of waiting, I have my solar panels installed and connected. The panels itself, they were installed during the winter. I shot a video about that. But then I was waiting for them to come and finish the installation in the house and all the cabling. So this is how it looks like. There is the inverter mounted below the ceiling. It's a GoodWe inverter, which is good because you can integrate it to the Home Assistant. And below that, there is the switchgear with all the fuse boxes, and under that, there is the battery. So this is 10 kilowatt hours battery that I use to run the house during the night, and there's no sun. So they did that a few weeks ago, but then I was still waiting for the utility company to come in and connect it to the grid. In fact, it was connected, but I had to keep it turned off because, first of all, they had to exchange the power meter to account for energy import and export. And also they needed to install the emergency switch so they can remotely turn it off in case they don't want the energy. So I wasn't allowed to run it until then. And finally they come in Monday afternoon. So from Monday evening, I was able to run the power plant. So what I'd like to do in this video is I'd like to show you how it works, because I have configured some, I think, quite interesting automations to manage the load charging on my electric vehicle based on the solar production, and it works surprisingly well on first try. So I'd like to show you how it works, how it looks like. And then I'm gonna make one more video where I'm gonna actually walk you through the automation, because I have few other automations as well. So I'm gonna walk you through them and show you how it's done, so you can actually get some inspiration and maybe do something similar yourself as well. But I'd like to keep it short, so this video is gonna be only to show you how it works and what it does. So let's come with me. So now that we have everything set up, let me explain to you how I manage energy in my house. This is the default Home Assistant energy dashboard. I quite like it. It's very simple, so you could see very easily what's going on. On the right side, you have the energy distribution dashboard that shows you energy flows between the solar panels, battery, the grid, and the house. It's quite nice with the dots showing which direction the energy flows, and there are some statistics, the numbers, the kilowatts exported, imported. On the left side, you have the distribution throughout the day. So you could see that the orange one is the consumed solar, the red one is battery charged, and so on. So it's quite useful. There's a solar production chart below that, and on the very bottom there are detail for different appliances. But I'm not gonna use this chart to tell you the story, because I'm gonna use something slightly more detailed, a lot more detailed maybe. And it's maybe too confusing and complicated, but don't worry, I'm gonna explain that to you. First, to make it simple, let's ignore the gauges around the dashboard. These are just showing the current consumption of different appliances. Let's ignore it. I have three charts in the middle. And what I'd like to explain to you is mainly this red blob on the left in the middle. And this is charging of my electric vehicle. And this is one of the things which I manage through Home Assistant automation. I have automation that I'm going to explain in the next video that is automatically turning on and off the charging of the vehicle based on the sun production, also depending on the mode, which I can set up. And it's adjusting the charging current based on the solar panel. So I'm charging the car only from the solar panels, not from the grid. So this is one of the automations I use for energy production, managing my load, in this case, charging of the car according to the solar production. I have a couple of other things. There is one automation that is making sure that if there is severe weather warning, I'm going to charge my battery and be ready for power outage. And there is few other things. But I'm gonna focus on this one and tell you what has happened during this day, because this was the very first day I have turned on my solar power plant, and it was quite an interesting day because everything happened throughout the day. I'm gonna explain to you. But first, back to the car. So here in my house, in the garage, I can set up, there are different modes for the charging of the car. The first mode is fast. That means it's just charging the car. When I plug it in, it'll charge it full power. This is the default mode. When the car leaves the house, it'll automatically switch to the fast mode, just to make sure if I plug it somewhere on the street that it's just charging fully as fast as I can. The other mode is scheduled, and this is automatically selected when the car arrives home. And that means that it's automatically managed to charge it from the solar panels, but making sure that it is charged in the morning before I leave the house. It's charged minimum 70%. I can adjust the number in here. So this is 70%. The other one is available. Maybe I will rename it. I'm not sure if available is the right term, but what it means is just charging it from the available solar productions. So when the sun sets, then it'll basically stop charging even if the battery is not charged. And this is the default mode for the weekend. But I can obviously change it. So this is where I set up how it's supposed to work. And then this is the result. So let me tell you the story, what was going on. So this is the very first day I connected the solar power plant to the grid. So the battery was charged to 20%, which is considered the minimum I discharged the battery to. So it was not charging before. So during the night, the house was running from the grid. So let me explain you the different charts. The first chart shows the overall flows of the energy in the house, right? So the yellow one is the sun, like the color of the sun is yellow. Then the green one is the battery. So I'm using green for the battery because it's considered green. If it's below the line, it means that the battery is charging. If it's above the line, it means that the battery is being used. Then I have the red line, and I use red color because that's something I'd like to avoid. This is the grid. If it's below the line, it means I am using energy from the grid. If it's above the line, it means that I am exporting to the grid. I didn't export during this day too much because there was quite bad weather. I'm gonna explain a bit later. And there are some short peaks, then the grid was used. I'm learning that the inverter is perhaps not very good at reacting to very fast changes of the energy. So if I turn something on very quickly, the inverter is going to cover the peak from the grid, but then very fast it's going to pick up and stop using the grid. And finally, the blue line is the house consumption. And for the blue line, there is a detail in the second chart where you can see the different appliances, what was using the energy. So the middle chart is essentially the detail of the blue line in here. And finally, the third chart is the state of charge of the battery. So you can see in the morning it was 20%. Throughout the day it went to 98, 99%. And then in the afternoon from 3 o'clock, it was gradually being discharged because there was no sun anymore. So speaking of the sun, it started as a beautiful day. You could see the smooth yellow line, clear skies, very beautiful day. So there was sunrise at around 6:52, 7 o'clock in the morning. The sun started to rise and the solar energy was gradually very smoothly increasing until 10 o'clock, 11 o'clock in the morning. And then you could see this jagged line, the first cloud started to arrive, and then it was pretty much cloudy day. There were some moments where the sun shined through, but in the afternoon it just became, from 3 o'clock, a horrible day. It was actually snowing. It was quite dark, and And this is actually how the day looked like. So from that on, the house was pretty much running on the battery. So now that you know what was going on, in the morning before the sunrise, the blue line, the house was using 700 watts and it was all taken from the grid because the battery was empty. Now the energy management for the car kept the charging off because there was no solar production, right? So it was off, but as soon as the sun started to produce energy around 7 o'clock in the morning, the automation started to adjusting the charging current through the Škoda API. It's set it to 735 watts, which is 3 amperes or whatnot. And then gradually, in 10 minutes interval, it was evaluating it, taking into account also the consumption of the house, and it was increasing it as the production of the sun was increasing until it reached the moment at around 8 o'clock in the morning when there was enough energy, so the car was charging on the full power supported by this wall box and by the car. So it was charging on 2.5 kilowatt, and it was running in there. There was also some surplus of energy, so the green line here, that the battery was being recharged a little bit, so you could see the battery state of charge being increased even during the charging of the car. This is interesting moment in here at around 9 o'clock in the morning that we have turned on the washing machine. So the yellow ones, these are coffee machines that are being turned on as well, but they're very short. But the blue line is washing machine, which is using 2 kilowatts for quite a long time. So as you can see, when we started the washing machine, first the battery reacted and it's starting to contribute to the consumption of the house. So both charging the car and the washing machine. So it actually ensured that I'm not importing any energy, and the house was running fully independent from the grid. But the automation actually spotted that, and it decreased the charging current of the car just to make sure that this overall house consumption is below the solar production. So it actually achieved that. So it's quite interesting how it reacted. And then after the washing machine was heated up and it stopped washing, it increased it back to the full power until the car was fully charged, and from that moment on it actually increased the charging power of the battery in the house. So you could see that the state of charge starting to increase quite rapidly in here until around 11 o'clock when first clouds started coming in, and it actually very soon became very cloudy, so there was not much solar energy coming through. There were a few moments where there was some sunshine, but in the afternoon it was actually quite a horrible day. It was snowing, it was quite dark very soon, so the house was running. As you can see, this green line here, the house was running from the battery, and this red color in here, this is the oven. So we were baking something actually in the oven twice, here at around 3:30 and then in the evening again. So we were quite heavily using energy at this moment. So you could see that the state of battery was decreasing quite rapidly because of that. But we were covering all this from the battery, because you see the red line in here, it's pretty much kept on zero except those short moments in here until 6 o'clock in the morning. It was covering the consumption of the house throughout the night, and I was doing actually some 3D printing throughout the day. So the house was using 400 watts the whole night because I was printing on 3D printer, as well as the gas heater is using 100 watts and whatnot. So this all covered throughout the night until 6 in the morning, and then you could see that it started to use energy from the grid because the battery was back on 20%. So this was the first day. Now let me show you today, which was actually more interesting. So today it was more sunny day and I wasn't charging the car. So this is actually the same moment we ended yesterday. So this was 6 o'clock in the morning. The house started to use energy from the grid until about 7 o'clock in the morning, when the solar energy started to cover the house consumption again. So then it was covering the consumption of the house, plus it started to charge the battery because it was quite rapidly increasing. There were a few clouds, but overall it was quite nice and sunny day throughout the whole day till the afternoon, till basically 4 o'clock in the afternoon when there was a sunset. So you could see in the morning the sun was covering consumption of the house. There were a few things. There was a dishwasher running a few times. So these are the different blue bars that are actually representing the dishwasher. And again, so this was actually running quite long, or maybe twice. And then it was charging the battery until in here at 10:30. The battery was at around 90%. So then the battery charging has slowed down until the battery was fully charged at around 11:40. And as the battery charging was decreasing, you could see that the house started to export to the grid. So you could see that it's now exporting some 3 kilowatts, and it even increased later on to 4.5 kilowatts export. And the export was decreasing as the sun production decreased. Now, this is obviously not managed by Home Assistant. This is managed by the inverter that is managing the different flows. The only thing which was managed by the Home Assistant is this managing of the car charging. And there are a few other things that I am automating, and I will automate a little bit more. But I wanted to show you how it works in real. I have it second day, so this is still quite fresh, but I'm quite pleased, especially with this one, because I was making the automation without being able to test it, and I turn it on and it works quite nicely. So this is how it works. I'm actually quite pleased with that. I thought it will work, I was hoping it'll work, but it actually quite nicely surprised me how well it worked. It was quite nice, and I will still keep it running and fine-tune it. One of the things I'd like to add in the future is to look at the solar irradiation forecast, and maybe do not just react on the current energy, but also do some planning ahead. But that's something that I will be working on throughout the summer, so I can always keep improving it. So I hope you like that, and I'll see you in the next one. Bye.